So now our last 4 questions of homework assignment number 1. Yeah. Let me give you some hints. Yeah. One by one. Yeah. All right. So let me start with number 22 first. Yeah. So in this question, first, you need to take advantage of the special structures. Okay? Yeah. So for questions like this, the structures, very important. Yeah. You should not break the structure. Don't break the structure. Here, let me write it out. Yeah. The first thing you really need to be careful here. Yeah. So don't break the structure by expansion. Don't do expansion, okay? Yeah. Don't do expansion. Otherwise, you would get too many terms. Then you count the number of multiplication, too many multiplications. Yeah. All right. Next, now we need to find special properties of the special structure. Yeah. So what kind of special property? Yeah. So number 2, you need to be able to identify the structure of this polynomial is related to the Pascal's triangle. Okay? Yeah. You need to make that connection. Okay? All right. Yeah. Consider that connection to the Pascal's triangle. All right? Yeah. So in our module 1, yeah, module 1, part B, yeah, last topic. Okay? All right. So module 1, part B, last topic. Okay? All right. Yeah. All right. After that, so you can, make your polynomial with more compact structure. Yeah. Because this expression still, too long, right? Too long. You want to make it more compact. Okay? Yeah. So step 3, get a more compact expression by the binomial formula. Because this formula, binomial formula, related to the Pascal's triangle. Okay? Yeah? So you have a, Then the last step. Yeah. Because in your expression, you need to calculate a of x plus b of x inside the parentheses. Okay? Yeah. So then you have something outside. Okay? All right. But inside the parentheses, ax plus bx, then you need to do another step to, make your expression more friendly. So you need to get a more friendly form to save some number of multiplications. Okay? Yeah. So you need to, get a more friendly form for multiplication saving. Let's say in this way. I hope you understand the meaning. Okay? Yeah. You need to get a more friendly form for multiplication saving. Okay? Yeah. Save as many as possible multiplications. Yeah. All right. Yeah. All right. And another step. All right. So even after that, last step. Here you can see, you need to have the knowledge background from so many pieces. Yeah. All covered in module 1. Yeah. Yeah. So you need to connect the dots to all those pieces. Yeah. So the last step, you need to apply the Horner's rule. For the final form. Okay? This final form is that, friendly form. That friendly form. Okay? Yeah. See? Yeah. Then you can answer this question well. Okay? Yeah. Here you can see this question is designed to, really check your knowledge, understanding, the technique, understanding. All right. Next question. Yeah, this one. Number 23. Yeah. So this question, in order to solve it, you really need to get that insight. Some, very special insight. Yeah. If you did not get it, then when you work on it directly, you may use too many comparisons. Okay? Yeah. Yeah. So here, that's a common problem. If no insight, you may use too many comparisons. All right? Yeah. That's the problem. Okay? Yeah. But this insight, to discover, to get this insight, so you need to make connection. So there is important connection. Here, I want to point it out. Connection. What's that? We learn. So one problem in our module 1 part D. Yeah. So finding so here look at the top 6, okay? All right. So finding our original problem, finding the minimum, but here I want to use the version finding the maximum. Similar, right? Similar. But for the version of this problem, finding the maximum is better. Okay? Yeah. So I use the version finding the maximum of an array. Okay, all right. So we know n elements. Okay, yeah. N elements. All right. Now, here you can assume distinct elements. Yeah, because the equal case, not quite. A little more discussion, right? Yeah. So here you can assume, distinct. Yeah. Okay. Yeah. Because later, if you don't have the distinct condition, you can modify your algorithm easily. Yeah. After you get it, you modify your algorithm easily. Okay. All right. Yeah. All right. So then. The formula, we know, yeah. So for this, even the maximum version, we have the same formula for the minimum version, right? Yeah. So formula is n minus 1 comparisons. All right, so recall. So here, connection. So let's connect to this question. All right. So here, I want to point it out, the structure, from the structure of the question. Yeah. One special structure out. Yeah. So this finding the maximum, I want to rephrase the sentence to the one much closer to the statement in our current question. That's what I want to do. Yeah. How do I rephrase the sentence, finding the maximum? Finding the maximum, okay, all right. That's just finding the element D, okay, yeah, so here D, yeah, because only one, right? Yeah. So the general case A or N, yeah. Yeah, so N, yeah, actually, because element, right? Yeah. So the general case, because general case may not be only one, right? Yeah. So general case M, yeah, the maximum case D element. That is among the top one. Top one. Because maximum, top one. Okay? Although you do not have room, right? Top one. There must be the one in it, in top one. Yeah, only one in top one. But you can see with this rephrase sentence, yeah, the only difference is 1 versus 6. So this question, we need to find one among top 6. Top 6, top 1, the difference is only that number difference. Okay? Yeah. Top some number. Okay? Yeah. So if we consider the general case, top K, yeah, top K, in this question, K equals 6. In this question, K equals 1. Think about that. That means when you solve question number 23, you can borrow your experience from our known. This is the known problem. Yeah. We know how to solve it. So known problem. Yeah. So this one, you look at the module 1, part D. Okay? Yeah. Study that. Yeah. Then you need to do some analysis. Yeah. So what's the difference? Top 1 and the top 6. What's the main difference? So here we need to consider main difference between these two versions. Okay, all right, so that number. Top 1, so the solution element must eliminate n minus 1 elements to be top 1, right? Yeah. How do we get top 1 element? Okay? Yeah. All right, so let me write. Yeah. Old version, the solution element must eliminate n minus 1 elements by comparisons. Okay? All right. That's old version. Now you need to, adapt it to a new version. Adapt the old version to new version. Okay? New version. Yeah. For the new version, the solution element need to eliminate at least certain number of elements, okay, certain number. So you need to figure out this certain number. What's that? Okay, yeah, what's that certain number? Yeah, old version n minus 1. Okay, n minus 1 corresponds to top 1. Corresponds to top 1. Okay, this certain number corresponds to top 6. Okay, corresponds to top 6. Then you figure out when you make this connection is the insight. Okay, because that's the insight. So if you understand this insight well enough, then you can find a solution quickly. Yeah. Okay, all right. So that is the question number 23. Yeah. Question number 24, yeah. So last two questions. But last two questions, there is one special thing you need to pay attention when you write your solutions. Yeah. Here, look at the word. I ask you to write solutions. Okay, solution, yeah. All the previous questions I asked you to write answers. Yeah. So from the different words I use here, for answers on paper, you only need to give me the final answer. Okay? Yeah. I do not require you provide me all the details. Yeah. Only need to give me the final answer. Okay? All right. But solution, yeah, when you see solution, you need to provide the solution details. The detail is important, okay? Details for full credit. Otherwise, you can only get a partial credit. All right? Yeah. But another thing is, for the answer version, yeah, you can earn partial credit. Okay? Yeah. So I give you a chance to earn partial credit by giving key steps. Erase. Sorry. Yeah. Key steps. Okay. Yeah. To earn partial credit. Okay. Yeah. Yeah. Because sometimes your answer could be wrong if you do not provide some important steps. Then I do not know your solution details, so I can only give you points based on the final answer. Yeah. All right, so now even if your final answer is wrong, but if you can provide me some important steps that based on the information you provide, I can give you partial credit. Okay? So if your method is correct, yeah, so then you can earn more partial credit. Okay? Yeah. So 1, 2, 3, yeah, partial credit, full credit, 4 points. So you have chance to earn 1 or 2 or 3 points based on how close is your answer, solution, key steps close to the correct one. Okay? Yeah. So that's important. All right. Yeah. So other than that, yeah, let me talk about the hints here. Yeah. Hints in this question. All right. Here, yeah. Let me read the question first. So then I'll give you some ideas. Given a 7-element array with distinct elements, yeah, it is known that there is a condition. Yeah, x7 is not the maximum. Okay, not the maximum. All right. What is the minimum number of comparisons you need to find an element that is neither the maximum nor the minimum? That's the question. Okay? All right. Yeah. So first, yeah, when you start, you need to do one important step at the beginning. Yeah. So what's that? All right. Yeah. Because before you find a solution, you have no idea how many comparisons you need to solve this problem, right? You have no idea. At the beginning, you have no idea. Yeah. So the first question is, what is your target? What is the target number? Yeah. So let me ask this question. Yeah. What is your target number? Do you know the meaning? Target number? Yeah. What number is your target? Okay. Yeah. 10 comparison is a target, or 5 comparison is a target, or 3 comparison is a target, and so on. Right? Yeah. First, can you estimate? Right? Right? Yeah. So here, estimate. Okay. Estimate or guess. Remember the guess. Remember the guess and verify strategy, right? Yeah. For the solution, you need to make a guess to set your goal. Okay? Yeah. So set your target. Yeah. So then you try to, get that target. All right? Yeah. So that idea. So now, let's consider. Because when we make a guess, we don't want to make a baseless guess, right? So we need to have some solid base information to help us get a guess. Yeah. All right? Yeah. So we need to do this. Yeah. Yeah. Some analysis here. All right. So now we want to find an element. Yeah. Neither maximum nor minimum. All right? Neither maximum nor minimum. All right. Okay. All right. So here, let me draw a diagram. Okay. All right. In this diagram, we need to find element. So this is our solution. First, this solution should satisfy two conditions. The first condition, it cannot be the maximum. It cannot be the maximum, the first solution. That means there must be at least one element that is above this solution element. At least one element is higher. Higher means has greater value than this solution element. Yeah. So that means you should be able to find one element that is above this element. All right? Similarly, it cannot be the minimum. That means you can find at least one element that is below, smaller than this element. Okay? At least one. That's enough. You don't need more than one, right? Yeah, at least one. All right. Then, if you can get to this step, this is a critical step. This step, critical step. Then, here in this diagram, three elements involved, right? In this small diagram, three elements involved. All right? Yeah. Okay. All right. Then you can select arbitrary three elements. Yeah. You only need to use three elements. Okay. All right. So when you select arbitrary three elements, the solution one is the median, because it's in the middle in values, median of the three elements, three selected elements. Okay? All right. The question, given three elements, how many comparisons you need to find the median? Okay? So that number. Given three elements, how many comparisons to find the median? Okay? All right. So this question. Simple question, right? How many comparisons to find the median of three? Median of three. All right? Yeah. Easy question. You can solve it easily. Yeah. All right. So the answer is three comparisons. Right? Yeah. Because you can sort. You can sort three elements, then the one in the middle, that's the median. Yeah. And you cannot do better than three. Yeah. Because here we need to consider the worst case, right? Some students may want to argue it's possible to use two comparisons to find a median, but if you look at closely, that two comparison is not the worst case, it's the best case. Yeah. but we want to work on the worst case. So the worst case, you need that 3 comparisons. All right? So with that answer, you can see, yeah, now we get back to this question. Yeah? Because if we ignore this condition, okay? Yeah. We ignore this condition. Then we solve that modified question, 7 elements. We can do this way. We do this way, the solution number, the target. Remember, I talked about that target. That number, we can use 3 comparisons to find the solution. Okay? That's under the condition we ignore the given condition. Okay? All right. After that, then we add that condition back. Add this given condition back. X7 is not the maximum. So we have more information, more useful information. Yeah. So X7 is not the maximum because it has some information related to the maximum. So we estimate, we figure, so we estimate this information should be useful for our solution, should be useful. If it is useful, that means this condition can help us reduce the number of comparisons. Reduce, yeah? Because we are guaranteed to use 3 comparisons to find a solution. The question, can we do better? So the question, if we use the given condition, if we add this given condition, can we do better than the case without given condition, right? Yeah. So this tells us, we hope, yeah, because we figure this condition should be useful. By using this useful condition, at least we can move 1 step forward, right? 1 step, to make our solution better, right? Yeah. So that means our target. So now I can talk about a target. Target, reduce 3 to 2 comparisons. All right, 2 comparisons. Okay, that's your target. Okay, that's your target. So guess. So we make it a guess. Yeah. So our analysis is the base for our guess. Okay? Yeah. Solid base for our guess. Okay, all right. Yeah. Then, how to get these? So now you try to get those 2 comparisons. Yeah. Yeah. Because it's a solution, you need to give me the detailed steps how to use 2 comparisons to find a solution. That's your goal. Okay, all right. But then the last sentence I want to give you, yeah, because the next step still pretty challenging. Okay, all right. So I give you another piece of helpful information as part of the hint. Yeah. So what's that? All right. Now you need to do the specific comparisons, right? Yeah. Comparison 1, comparison 2. Okay. All right. But when you do comparison 1, comparison 2, you need some guidelines. You need to, because your computing resource, very precious. You only have 2 comparisons as your computing resource. Very precious. You don't want to waste your precious computing resource. Okay? So you want to use your precious 2 comparisons wisely. Yeah, wisely. Okay? All right. So here, the next question. How to use the precious two comparisons wisely, all right, there is one important, strategy here. We'll talk about the strategy. Okay, try to maximize the information we can get from the comparisons. Yeah, so we want to implement that strategy. Yeah, how to maximize? All right. So here, now let's consider the first comparison. Yeah. So here I don't have a lot of room. All right. Yeah, I use up too much room. Okay. All right. Yeah. Let's try to squeeze a little bit. Yeah. Use the space here. Okay. All right. First comparison. First comparison, we want to get the maximum information from the first comparison. Maximum possible information for the first comparison. All right? Yeah. So how to make it? Now, all right. Here, if we look at all the elements in these 7 elements, which element is special? Which element is different from all the other elements? Only one. One at X7 is special. Okay? All the other elements the same. Not special. Element 7 is special. Why? Because it has this extra condition, not the maximum condition. That information. All the other elements, we know nothing about all the other elements. For X7 element, we know partial condition, right? Yeah. So we have some partial useful information for X7. So X7 has more information towards the final solution. Yeah. It's different from other. Okay? So that means X7 has more value, right? Yeah. Regarding our solution finding, so X7 has more value, okay? Higher value than all the other elements. All right. Then when we do the first comparison, you need to find 2 elements in these 7 elements. Two of the 7 elements. But when you choose 2 of the elements, do you want to include X7 or not include X7? Okay? Yeah. So here you have 2 different ways to choose for your first 2 elements. Yeah, because you need to select 2 elements, right? Yeah. So the first way, include X7. Second way, not include X7. Now you want to figure out which way you can get more information. Okay? Which way you can get more information helping you to get a final solution. That's another important step. When you make a decision, you need to choose the one that that provides you more helpful information. That's the thinking. That's the critical point here. Yeah. All right. Option 1 or option 2 here. Okay. Yeah. Option 1, X7 and another element. Option 2, 2 elements that have nothing to do with X7. Yeah. X7. Okay. Yeah, 2 different. Yeah. All right. You need to compare. So which one is better? Which one you can get more information? Okay, that's the critical step. Yeah. All right. Here, yeah. Although I can ask you to think about it. Yeah. Here I tell you the answer. Option 2 is better. Okay, option 2 is better. Yeah. So here, why option 2 is better? Not include. not include X7. Yeah. It's better because if you use option 1, X7 already contains some useful information. Then you do one comparison with partial known. Yeah, we call X7 has partial known information. Yeah. The other element is completely unknown, but X7 has partial known information. All right. Then you do comparison. You get information of one comparison, but because X7 is partial known, that means the additive useful information you get is smaller. Additive, right? Yeah, because X7 already occupies some partial useful information, but the whole information from one comparison is fixed, right? The total information, the total useful information from one comparison is fixed. Okay? But X7, partial known, the partial known element is involved in one comparison, so the additive part, yeah, the extra, the information more than that partial known part is smaller. Yeah, the additive part is smaller. Then option 2, you do not include the partial known element X7, both unknown, so you get a full additive because all the information is additive, right? Yeah. So you add a full comparison information to your, valuable information towards the final solution. That's why option 2, you can get more information than option 1. Yeah. All right. So after you first compare, one is larger than the second one, then you use the second comparison should based on the result of the first comparison. Yeah. Because first comparison, you compare one larger, one smaller, okay? One larger, one smaller. So then the second comparison should be based on the result of the first comparison. Right? Yeah. So then you complete the whole solution. Right? So here, I provide you a lot of information, a lot of useful information. Yeah. Okay. Yeah. Yeah. Let me say, approximately half of the information of the solution. I cannot give you 100% solution, right? Yeah. So that's not good. Okay. I need you really solve the problem by yourselves. Okay. I should not give you, free solution. Yeah. That's not fair. Okay. So you need to complete the remaining 50% information for the solution. Okay. All right. So then our last question. Last question, so far at this point, I already spent a lot of time, but the good thing about last question, so my hint is very short. Although this question, so if you work on it directly, it could be very challenging, but the hint idea is very simple, very short, okay? Yeah, so I can give you quickly the hint information. Yeah. All right. So for the last hint, let me do it this way. So the given condition, these three inequalities, we work. Okay. All right. the first, so x2 higher x1. Okay, all right. So then the second pair, x4 higher than x3. Yeah. All right. The first thing you need to do, you merge these we can treat as two ordered, because they are ordered, right? Two ordered subarrays. To get, to sort. Yeah. So what you're doing basically. Yeah. So here. Why I cannot erase this? That's strange. Well, yeah, finally, yeah. To sort these four elements. Okay. Okay. Yeah. So you need to figure out the minimum number of comparisons you use to sort these four elements. Okay? All right. Yeah. So that's the first step. Yeah. Yeah. First step. Okay? Do this. Yeah. How many? Yeah. It's not too hard. Yeah. It's not too hard. Yeah. Only four elements. Yeah. But you can use the information, order here, to help you reduce the number of comparisons. Yeah. All right. After you have that, then the second step. So here's step one. Yeah. Step two. All right. Now, so let me draw another diagram. Yeah. Here I assume after sorted, so you have four ordered elements, right? Yeah. Here for simplicity, we can assume these four elements ordered like this. Okay? Yeah. Yeah. Because there is some order, right? Yeah. There is some specific order. Yeah. Yeah. And we can use one of the several different orders as the representative. Yeah. Here we just use this case as the representative. Yeah. So it's fine. Yeah. All right. So then another one, also a shorter ordered array. Yeah. X6, X5. All right. Now you can, try to find the four elements. Okay. All right. Two smallest and the two largest. Okay. All right. Largest, you work on the top end. Yeah, the top end. For two largest. Okay. Then the lower end. Yeah. So you do comparison from the lower end for two smallest. The first smallest, second smallest, okay? Yeah, that should be pretty easy, pretty straightforward. Then you find solution, okay? So using these two steps, you can find a solution easily, okay? All right, so not very complicated, yeah. All right? So that's the, for the most of these challenging questions, so I give you, plenty of useful information. So if you have a pretty good understanding, so you should be able to figure out those solutions. Yeah. All right, so that's the amount of hints information I want to give you. Okay, all right, so then try your best to complete to get the best grades from this assignment. Okay, all right, so let me stop.